Hello everyone, and welcome to another Adventures in Kubeland stream. I'm Luca Lanziani, and this is part of a series where we explore Kubernetes and the CNCF landscape. So, but without losing much more time, let's jump into the content for today's stream, that is Flux. So, what is Flux? Flux is one of the two main CDs for Kubernetes. If you follow the previous one of the previous episodes, you will know that we have two type of CDs. We have seen in the past Argo CD, that is one of the CD that I prefer to use on Kubernetes, but the other main competitor in this space is actually Flux. There are pros and cons, right, on those two, and there are people that obviously prefer Flux, and there are people that obviously prefer Argo. I'm on the Argo family, but nevertheless, I want to show you what Flux is capable of. Flux has, the page say, is now part of the CNCF, and that's why we're looking at it. And Flux was launched a long time ago, probably around the same time of Argo CD and evolved with it. So let's look a little bit of what Flux does, right? In the web page, in the first web page, that is fluxcd.io. If you don't know where that is, we have Flux in short. Let's see for a second. So Flux provides GitOps for both apps and infrastructure. Flux and Flagger. Oh, by the way, yeah. So Flux is not the only tool in here. You probably have to couple with Flagger to do certain things, right? Deploy apps with canaries, feature flag, and AB rollouts. Flux can also manage any Kubernetes resource, infrastructure, and workload dependency management is built in. Git, just push to Git and Flux does the rest. Now, this is interesting because I'm pretty sure that Flux supports more than Git, but Git is probably the main thing, right? Flux enables application deployment CD and with the help of Flagger, progressive delivery. So see, that's why I say probably you also need Flagger. If you want to enable some of the functionalities like the canaries, feature flag, and so on, probably you need the Flagger add-on, right? Through automatic reconciliation, Flux can even push back to Git for you with automated container image update to Git. Okay, interesting. I would like to understand what they mean by this. We can go deep on that later. Flux works with your Git providers, GitHub, GitLab, Bitbucket, and even with S3 compatible buckets as a source. So this is what I was telling you about, right? So, where is it? So they're mentioning use Git, right? But then down here they say, okay, yeah, Git just push to Git and Flux does the rest. But then they clarify that they can also support, and they support S3 compatible buckets as a source. This can make sense in certain environments. I rarely use it as an S3 as a source. Pull versus push. Least amount of privilege, adhere to Kubernetes security policies, and tie integration with security tools and best practices. So what this is saying is that many workloads work in a way where you actually build things and then you push it to the cluster. In this specific case, we don't do that, right? We are in the cluster, and Flux is basically monitoring the source of information, right? You can monitor, as they say, Git with multiple provider or S3 buckets, and from there it's actually pulling data in. So it's pulling whatever is there, it's pulling the manifest, and it's pulling that in. And this is a different approach because that means that you don't have to configure your credentials in pipeline, right? You don't have to even have access from the outside to the cluster. The cluster could be in theory private, right? And then it's the cluster that is reaching out to those places to pull information. That's what they're saying here, right? When they say security in mind. So let's move on. Flux works with any Kubernetes and all common Kubernetes tooling. Customized Helm, RBAC, and policy-driven validation, OPAC, Averno, and mission controllers, so it simply falls into place. So as we have seen in the streaming about Argo CD, how Argo CD could load. Actually, I don't know if we have seen that in details, but Argo CD can load different type of manifest. It can load plain manifest, so YAML file, and even recursively in directories, right? And then you can load Helm chart and you can load Arbex, right? Helm chart, customize, and you can also load JSON, if I'm not mistaken. So they're saying to you that this can do something similar as well, right? You can actually do customize Helm, Arbex, and policy-driven validation with Open Caverna. And then Flux does multi-tenancy and multi-everything. What does it mean? Flux uses true Kubernetes RBAC via impersonation and support multiple Git repositories, multiple cluster infrastructure, and apps work out of the box with cluster API. Flux can use one Kubernetes cluster to manage app in either the same or other clusters, spin up additional clusters themselves, and manage clusters, including recycling fleet. Interesting. I would like to expand this, understand what they mean. That is good to know, right? That you can do more than that. So let's see what else. Flux alert and notifies. So Flux alert and notifies. Flux provide health assessment, alerting to external system and external events handling. Just git push and get notified on Slack and other Slack system. Okay, so you can actually notify when something happens, right? Flux is a CNCF graduate project and was categorized as adopt on the CNCF CI/CD Tech Radar. I don't know if you know this, but there are many CI/CDs, right, in Tech Radar. We can look at that later. And Flux has a lovely community, of course. Right? We welcome contribution of any kind. The components of Flask are Kubernetes core controller runtime, so anyone can contribute in its functionality. So what they're telling you is that as for Argo CD, this runs as a controller runtime, and that's the interesting part, right? It's another controller that runs on the cluster and can do things in there. But let's move on, right? Let's see what we can do in here. So on docs, we go to Flux, and we brought to this different documentation. For Flux documentation is a tool for keeping Kubernetes cluster in sync with sources of configuration, like Git repository, and automatic updates configuration when there is new code to deploy. Flux is built from the ground up to use Kubernetes API extension system and to integrate with Prometheus and other core components of the Kubernetes ecosystem. So fantastic. Another piece of information here is telling us that Flux can integrate with Prometheus. It's probably can expose metrics, right? It's probably going to expose metrics out of the box. Interesting to see. Flux support multi-tenancy. We have seen that it support for syncing an arbitrary number of Git repositories. Of course, right? I mean, the multi. It's interesting to me that they say that it supports an arbitrary number of Git repositories. This, from my perspective, should be a given. Wasn't that at the start? I don't know, right? But I would be very surprised to have a product like this not able to sync from as many Git repositories as we want. Flux works well with Flux very naturally integrate with these pieces of best practices of source software. So integrate with Grafana, Helm, Istio. I'm curious to know what they mean by. Okay. So looking at where we are redirected here, it says that probably to implement the progressive delivery is using Istio current deployments, right? And is doing that via Flagger. See? So that's what they mean by integrates well. And Grafana, because probably it's going to support custom metrics, it's going to support the metrics, right, to Grafana. Yeah. Okay. Yeah. And then Helm chart, Kubernetes, Caverno, Linkerd. So for Caverno, what does it do? Security image provenance. Okay, not interesting for now. And SOPs. Oh, okay. So SOPs, if you don't know what SOPs is the Mozilla way of managing secrets. I don't remember the acronym, what it stands for. But basically, it allows you to encrypt the secret with different keys, right? Even multiple, and then decrypt them on the fly. What is SOPs stands for? SOPs is another secret operations. Interesting. Secret operations. Today I learned, right? I knew about SOPs, but I didn't know what exactly SOPs stand for. Those are the same things that we've seen on the web page. Who is Flux for? Flux helps cluster operators automate provision and customization of cluster. Platform engineer build continuous delivery for developer team. App developer will rely on continuous delivery to get their code live. What can I do with Flux? Blah, blah, blah. Can we see something done? Okay, this is interesting. So let's look for a second at these schema. What is the GitOps toolkit? Flux is constructed with a GitOps toolkit component, which is a set of specialized tool and Flux controller, composable API, reusable Go packages for GitOps under the Flux GitHub organization. We can go there later. For building continuous delivery on top of Kubernetes, the GitOps toolkit can be used individually by platform engineer who wants to make their own continuous delivery system and have requirements not covered by Flux. Interesting. So they provide, so this is not differentiated probably from Argo CD. They do provide a library, right? They provide a GitOps toolkit that is pretty much related to the same thing. Is it? What is it? Oh, no, it's a specific page for that. Okay. And with some library that you can reuse, right? So, and it's the same, is this the same image? It looks like it's the same image. So can we look at that here? So there's the Kubernetes API, source customization, source controller, customized controller. Okay. So are those pulling? So is this pulling, I suppose, right? So what this is saying is that the API comprises Kubernetes custom resource, which can be created and updated by a cluster user. We know what the cluster resource is. We have seen it in the past, right? So Kubernetes has this idea of custom resource definition, where you can define your own resource in Kubernetes and you describe how that looks like, and then you can use them with controllers to, let's say, implement behavior in those resources. So the API comprises custom resources which can be created and updated by a cluster user or by other automation tooling. Yes, you can use the toolkit to extend Flux and to build your own system for continuous delivery. The Source Watcher guide is a good place to start. Yeah, I'm not going to look into this exactly, but this is an interesting thing, right? This is probably something we can do a full episode on. So let's keep going for a moment, right? Let's keep going here. Community, blah, blah, blah. Yeah, so let's start from the core concept of Flux. So GitOps. GitOps is a way of managing your infrastructure and applications so that the whole system is described declarative and version controlled. We know what GitOps is, so I wouldn't spend so much time on these. Sources. A source defines the origin of a repository containing the desired state of the system and the requirements to obtain it. For example, the latest .x tag available from Git repository over SSH. Sources provide an artifact that is consumed. Yeah, okay, whatever. So the sources are Git repository, OCI repository, Helm repository, and bucket. So what we're saying is that we can. So the origin of the source is checked for changes on a defined interval. There is a new version, obviously, that matches the criteria that's gonna pull the artifact. So in this case, GitHub repository, OCR repositories, Helm repository, and bucket. Reconciliation. We know what reconciliation is, right? You basically try to bring the desired state the same as the given state. Yes. So reconciliation refers to ensuring that the given state matches the desired state. Okay, probably the given state matches the desired state, declaratively defined somewhere. There are various examples of those in Flux. Okay, obviously, right, what they're saying is that each one of those Helm release, bucket, and customization may have different definition of reconciliation. So for Helm release, we assure that the state of the Helm release matches what is defined in the resource performer release. If this is not the case, bucket reconciliation downloads and archives the content of the declared bucket in a given interval and store it as an artifact, records and observes revision of the artifact and the artifact itself in the state resource. Customization reconciliation ensures that the state of the application deployed on the cluster matches the resource defined in a Git or OCR repos or S3 bucket. Okay, so you can do probably more than what we say, right? customization. The customization custom resource represent a local set of Kubernetes resources, customized overlay that Flux is supposed to reconcile in the cluster. The reconciliation runs every 5 minutes by default, but this can be changed, changing the interval and the spec. If you make any changes to the cluster using kubectl, edit, patch, delete, they will be promptly reverted. So this is what the idea of reconciliation, right? If you manually change things, they will be brought back to what they were before, thanks to the reconciliation loop. And this is a nice thing, right? This is exactly what we want. Who wouldn't want this? Cool. Bootstrap, the process of installing the Flux component in a GitOps manner is called Bootstrap. The manifests are applied to the cluster, a Git repository and customization are created for the Flux components. Then the manifests are pushed to an existing Git repository. Flux can manage, or a new one is created. Interesting. Does it really work that way? The process of installing the Flux components in a GitOps manner is called a bootstrap. The manifests are applied to the cluster. A Git repository and customization are created for the Flux components. Then the manifests are pushed to an existing Git repo. Flux can manage itself just as it manages. Okay, yeah, I know what I mean now. We can do a similar thing on Argo CD, right? There is no problem with doing this. So what they're saying is that you can push the resources, or install, if you want, install Flux to cluster, and at the same time start syncing or reconciliating from an existing GitHub or a new created GitHub repository, Git repository, and Flux is going to manage itself, right? In reality, what Flux does is applying those changes to the Kubernetes API, and it's Kubernetes that is then managing Flux. Okay, so what else? What else? What else? Let's see if we can actually apply something here. Get started. What do we have in get started? Before you begin, to follow the guy, you need the following: a Kubernetes cluster. We do have a Kubernetes cluster. We recommend Kubernetes kind. Look at that, right? Imagine what we have. As for every of those streams, get clusters. We have a kind cluster that is called streaming, always there for us, waiting for us. And if I'm not mistaken, kubectl get, or maybe let's use kubectl cluster config view. Oops. View. There you go. So we're actually pointing out kind streaming. And then GitHub personal access token with repo permission. Okay, I don't think I have this at the moment. So it would be interesting to see if I need that. I'm going to have to create that on the fly. Objective: bootstrap Flux on Kubernetes cluster, deploy a simple application using Flux, customize application configuration through customize patches. We can do that. So install Flux CLI. Flux CLI is something that is installed already. If you're not there, you can do it yourself. I personally follow the instructions in this page, and I'm lucky because I'm using Arch Linux, and so I just have to install Flux bin. So in theory, if I do Flux and tap, Flux is already there. So Flux-v, and I have a version of Flux installed. Export your credentials, and this is something that I don't have. So let me think. Do I really need to do this right now? Let's try to move on without this, right? So check you have everything needed to run Flux by running the following command: Flux check --pre. So this is like the pre-flight. Yeah. Okay. Pre-flight checks, right? For the cluster. And what it's doing is actually checking if Kubernetes it's major greater or equal of 120. We have 125 and we're okay. Install Flux onto your cluster, and now it's actually asking for this thing for us, right? Okay, let's do that then. So just so you know, I do have a new account in GitHub for this that is called Adventures in Kubeland. I can even show you this part here, right? So this is what I'm doing, right? I'm actually doing Flux stream, and expiration 30 days, but we're not gonna, 7 days is more than enough. So if by any chance I expose this, I can be sure that in 7 days it's gone in any case. Public repository, read only. And if I say do generated token, and if I do this in theory, you can even see the token, right? What type of permission do we need in here? Do they say? Do they say what type of permissions? They don't say. I could share this with you. This is classic token. Find great person. Oh, token classic. That's what we want. Generate a new token. A token classic. There you go. Flux. Stream. And then again, 7 days. Repo. User. Okay. So I now have my token, and now I'm gonna take this terminal. I'm gonna bring it where you cannot see it. I'm gonna export those just because I don't want to lose time, right? I'm gonna export these on the fly. Yes. So I'm gonna bring this back here, and now we have in the, sorry, let me do this. We have the 2 credentials that we need, and so we can move on. So in here, I can actually run this command now, copy, and if everything goes as I expect, wow, this is doing more than I was expecting, right? Did he actually just create a repo in my, oh, look at this. He actually just created a repo, and then I suppose that he's generating some access key for the repo, a deployment key probably. There you go, right? So that's what you've seen in here. So this is doing a lot. So let's see. And he also has created the content of the repo. That is interesting. So the content of the repo, if I go in here, let's see what's in there, right? It has actually created a fleet infra cluster, my cluster, and a bunch of components. So the output is similar to this. Yes, we have seen the output. And pushing the manifest. So the Bootstrap created a Git repository, fleet infra on your GitHub account. Okay. I don't like the fact that it took complete control, right? And it has done everything for me. But well, maybe it's a way to start this, right? Probably it would have been good to say this before running the command. They should have told you, look, it's gonna create stuff, right? It's not just gonna. Maybe this should have gave me a hint, right? But they should have told me. Someone from Flux is looking at these. It wouldn't be bad to have that documented before. I don't like when software does things that I don't expect. In any case, so, and then add Flux components manifest to the repository, deploy Flux components to your Kubernetes cluster, and configure Flux components to track the path cluster by cluster in the repository. So it has done the whole flow, right? So now in theory, I have Flux running on the cluster, and we also have dev Flux monitoring what is in that repo. Now they're telling me now you can clone the repo, right? I don't even know if I have credentials to clone this repo. Okay, username. This is adventures in Kubeland. Now add a pod info repository for Flux. In this example, uses a public repository. Pod info is a tiny web application made with Go. Create a Git repository manifest pointing to the pod info repository master branch. Okay, let's see. So it's not even making me use this fleet infra. It's now asking me to do it manually. Okay, no, the output. Oh, okay. So this is actually generating a manifest for me. So that's what it's doing, right? So if I do this, we're gonna have this type of output, right? So in Vim cluster, my cluster. Okay, this one I like, right? The fact that you can use the Flux CLI to generate manifests for Flux. This is nice. So you don't have to know the exact syntax of this. You can actually use the Flux CLI, and if they want to change the format, they can do it, right? Because they control the generation process. In this particular case, we're saying can Git repository. Again, this is a custom resource definition and is controlled by this API. So you should now, the cluster knows about Git repository managed by this API. The name is pod info, the namespace is Flux system, and the spec is saying that it's reconciling every 30 seconds. We're pulling from the master branch of this repo. Is this repo even there? Just out of curiosity, let's see if it's there. Oh, expect that to be there. It's part of the example. Yes, it's there. And what type of repo is this? They're pointing to the master branch of these, right? But is there anything in the master branch of these that is telling me what I'm looking for? Doesn't look like there is anything. So what's the convention? What is gonna be looking at? Does it tell us? Commit and push, okay, whatever. So let's keep following this. Git add dog git status. Git status, sorry, I don't have my usual Git shortcut in here. And pod info, I guess pod info Git repo. Fine, Git push, paste. There you go. And see, problem is that now I have no idea if Flux is doing that, right? Is it doing it? How do I know if Flux is doing it? So one key difference that we didn't touch upon yet is that Flux has no UI, or at least I remember that probably they added something not so long ago, but I mean, we didn't see any indication right now for a CLI there, right? So I would assume that if I do kubectl get repositories, what's the Git repository, get Git repository, and the namespace Flux system. So just to be clear, what I'm doing is actually checking those resource type in this namespace, so you can follow, right? So I just created this. In theory, pushing, I should have created this. So I want to double check that that is there, right? If I do that, you will see that pod info is actually here. So it looks like that once I push to Git, something has happened in the cluster that has synced the content of the repo. Not just that, but if you look at the status of that, it says that the status is ready equal true. So probably that is already pulled in and it's already applied whatever was there, right? Let's try to get more information from there. kubectl describe Git repository pod info -n Flux system. And what do we have in here? So yeah, blah blah blah, yada yada, and normal new artifact Git operation succeeded. So it's just pulled in this, right? So do I expect to have more, or I just added a? Okay, so you still have to do more than this. In fact, the next step is deploy pod info application, configure Flux to build and apply customized directory located in the pod repository, pod info repository. So when I was asking what is it pulling from here, that's what it's pulling now. So they want us to pull this part here, right? Those manifests here. And how do you do that? You do that by running Flux, create customization pod, blah, blah, blah. So again, this is generating a manifest. And let's see what it does. So Flux create customization pod info, target namespace default, path customize. So this is the path inside the pod info repo, and prune true interval export to. Okay, that's how does it match? How does it know that the source? Okay, the source is pod info. The source is pod info. And did I call the source pod info in here? I didn't change anything there, right? Yeah, the name is pod info. That's so it's telling you use the source pod info, use the path customize, and the rest it's all it is, right? So if I go into cluster, my cluster pod info customization, there you go. So it's telling you that you should have something like this, that it's basically doing what we just said, right? Look at the customize directory and prune through. Source ref is a Git repository. Pod info, probably the Git repository is the default. But that's what you do. Since we say that there are multiple type of sources, right? There may be a Helm, and what was the other one? It was an S3 packet, I suppose, right? In this case, it's a Git repository, and that's why the source type is Git repository. Okay. So the next thing, we want to apply this. So we run again this command, and since I don't have my password cached, I need to re-enter my password, but hey, git push. Watch Flux syncs the application. Okay, so now I can do this. Now I can do this. And since there's no interface, we're actually going to monitor what is happening there. Suspend it true, and then we see that there are a bunch of events occurring. So what is it doing? What is it doing? Flux system, pod info, waiting for reconcile, Flux system, pod info. There is a lot of information. It's not really clear what I'm looking for right now. Check pod info has been deployed in your cluster. So let's see if we have a kubectl -n default. So this is in the default namespace. Get deployments and services. And I'm expecting to see a pod info in here. Pod info is there. And pod info is there. And it's ready. So it did work, right? So I took whatever was in this directory, and let's see what was in this directory, because I deployed trusting the guy without double checking. But we don't have much time today, so I don't want to. So there is a deployment called pod info that does what though? Container images pod info. It exposes a bunch of ports. It runs pod info with port metrics and so on. And is executing. Okay, so the liveness probe is about check. Okay, doesn't tell me much, right? It's just some pod info. And the HPA. So in theory, it's telling us that it wants to scale horizontally. HPA is horizontal pod autoscaler, by the way, if you don't know about this, if you don't know what that means. Customization. This customization is the way you apply those. So it's actually starting from here, right? Saying I want to apply hpa.yaml, deployment.yaml, and service.yaml, and service. Okay, so the service is nothing. It's the cluster IP that exposes the ports. It's interesting that in this case, we are actually deploying a customization, right? And there's this one. And then we use customize to do the rest. Now, changes made to the pod info Kubernetes manifest in the master branch are reflected in your cluster, of course, right? When a Kubernetes manifest is removed from pod info repository, Flux removes it from your cluster. When you delete a customization from the fleet info repository, Flux removes all the Kubernetes objects previously applied from the customization. When you alter the pod info deployment using kubectl edit, the changes are reverted to the match they described in Git. Yes, of course. So of course, it's doing the reconciliation. That's what they're telling us, right? So if I do a editor, export editor equal beam, kubectl edit, let's say deployment pod info. I'll need to specify the namespace, because by default, the namespace is default. So if I go in here, and I try to change whatever, any of these, right? Let's say that I put what? I can change the replicas to B5, right? I do this, and I save. Obviously, that is edited, right? And I do kubectl get default. There you go. So in this case, you see that the app today is 5, ready 2 of 5, but in theory, scaled up, scaled up, scaled down. Okay, so who's setting the 4 here? Is it, so what is in the cluster manifest? So if I get, sorry, in the pod info manifest deployment, okay, so maybe the 2 was just the horizontal polyscaler, so I took the wrong example there, right? Let's try to mean ready version. Let's try to edit something else. I didn't realize that obviously we had the horizontal polyscaler, and that's what changed things, right? kubectl edit. So let's try something different. It should, I mean, obviously it would work with that, but if that was managed by Flux, but since it's managed by HPA, it doesn't work, right? Edit deployments, pod info, and mean ready seconds. We're gonna put this to 10. Okay, edited. And if I give it a second and I do describe pod info, do everything here. This is still 10. Come on, how long does it take? We say that every 5 minutes. So worst case scenario is 5 minutes, I suppose, right? This is annoying. In any case, so suspend updates. Suspending updates to a customization allows you to directly edit objects applied from a customization without your changes being reverted by the state in Git. Okay, this is useful. Okay, so reconciliation, it's very useful most of the time because if something changes, you want to put it back as it is. But let's assume that you are in an emergency, something is broken, and you want to troubleshoot or test something. Having reconciliation putting your state as it was before is a little bit annoying. So having the option to suspend the reconciliation for a little bit of time to test things is very useful. And that's what this is about, right? This is what it's for. You actually can run Flux suspend customization and the name, and then you can run resume, and that should be resumed. Customize pod info deployment. To customize a deployment from a repository you don't control, you can use Flux inline patches. The following example shows how you use inline patches to change the pod info deployment. Add the following to the field spec in your pod info customization YAML. Okay, file. So what is it doing? This is, by the way, in a previous episode, we have seen customize. And this is exactly using that idea, right? You can use the patches from customize to customize this thing. So in here, cluster, my cluster, in the pod info customization, what it's telling you is that you can actually define patches for customization, for customize. So you can do patches, all right? And this thing is gonna apply a patch to, and that's exactly the customized, this is exactly the customized syntax, right? It's gonna tell you, take the horizontal autoscaler from the manifest that we're loading, and the target is, here is where it's saying that, right? Target the horizontal autoscaler named pod info, that is the one that is in here. Horizontal autoscaler, this one here, right? Kind horizontal autoscaler name pod info. You can see that those two matches. And patch it, and this is a merge path patch, so it's actually merging the two with these. So what's going to happen is that it's going to take all of these, go to the spec, and change the main replica to 3 instead of 2. Now we also know why they went from 5 to 4 right away, right? Because max replica is 4. So HBA was looking at me and say, why did you put 5? I'm going to put it back to 4. And there's probably some time before it scales down. So if I do these, and if I can try, I can even try to do this, right? And copy these, paste it in here. There you go. This should be okay. Save these and git commit test patches. It does, the message, it doesn't matter in this case, right? Git push. There you go. So once we do these and we go back and we check for the deployment. Let's see if this is okay. So that is there, but let's also see if we can see get pods. Actually, let's do another thing, right? Get deployments. You remember that I pushed that to minimum 4. So we could still have 4 pods in there. So let's see what we have in here. Where's the replicas? We still have 4. So we won't see what we wanted to see, because this was supposed to scale up the number of pods from 2 to 3, but now we messed that up, right? But we can still check if the HPA is configured correctly, so we can go and check the horizontal pod scaler. So if I do kubectl, again, this is another customer's definition, right? Or a resource definition, sorry, not a customer's definition. kubectl get horizontal pod scaler. HPA, does it do it? Yes, HPA is a shortcut for horizontal pod scaler. Dash, and you can see the mean pods is 3. I don't even have to show you the manifest, right? But if I do dash o YAML, you can see that now, in this case, we should have max replica 4 and mean replicas 3. So the patch is working. We don't have mean replica 2, we have mean replica 3. That's an interesting way to do this, right? It's an interesting way to do this. Multi-cluster setup. So we are at the end of these. We've seen that we can do all these things. It's pretty interesting. You add the repo, you add the customization, right? Customization, and you're done. We didn't see how we can support the different type of sources, but we are at the end of the live stream. I want to keep going for another few minutes since we started late. So let's see what else we can see in here. We've seen it get started, and it all worked. Interesting enough, we were able to test it all. The installation is probably something that we've seen. We didn't see what's in the... Okay, let's have a look at what else is in the repo that is created, right? So what we didn't see is this one. So it's created a cluster with... Those are the things that we created ourselves, right? 3 minutes and 19 minutes. But what about the Flux system? Well, let's see what is in here. That's interesting. So the customization, nothing major, right? Again, it's telling you, please load the GRTK components in GRTK sync. So if I go in the GRTK components, what does it do? I'm expecting this to be a fairly big manifest. Oh yeah, it is, right? We probably don't want to go through all of this. So it's actually deploying what? Yeah, don't not edit. This is generated by Flux. Obviously, you don't want to touch it. Component source controllers, customized controllers, ARM controllers, and notification controllers. So it's installing the controllers. So in theory, and it's installing the customers' definitions, right? It's installing the CRDs. I mean, they're probably already installed, as we say, right? But it's just reconciling them once it's done. Then there's another thing that we can check before we start the stream. The other one is GRTK stream. Okay, and this is installing the repository. Okay, I see what it means. I see what it's doing, right? So what it's doing is installing the repository and the customization that points, look at that, to the same folder. See? Cluster, my cluster. It's interesting that, is it pointing to cluster myself? Okay, and then, so the path is this, but then, no, but it's interesting because it's missing the Flux system. So what is it looking for? So if you remember where we installed the other one, and I may be mistaken now, maybe I'm confused, but if I do a duplicate in my cluster, the pod info customization, is this the one? Yes, it's actually pointing to the folder customize, right? And if we go here in the folder customize, you do have customization. This one here, it's pointing to, sorry, this one here is pointing to the folder above this. So it's pointing to this one. Where is loading? Sorry, it's pointing to this one, right? So it's pointing to clusters, my cluster, clusters, my cluster. So it's looking where YAML is in here. Is it a recursive? We can test this. We can put something here and see if it's gonna be loaded, right? So if I try to move this file, clear, ls, clusters, my cluster, if I git move pod info customization into Flux system, I should probably not do this, but hey, git push, git commit, -m, moving things around, git push, less famous words, but hey, it's going, I'm doing fine. And so what's going to happen is that now I just moved the file into the audit directory. So if he's looking recursively, or if there's something in here, because that's something that I didn't check. That may not work because this is a customization folder. I think I just broken the kubectl get customization -a. Yeah, that's broken now. But it's definitely losing the kube system customization, right? The kube system customization is what we're... Okay, not the right way to do it, but it's definitely... Do we have this key repository? We do. I could try to change one of those to see if it works. Maybe that's better. So let's do that. Let's see if it's monitoring itself, right? So I'm gonna go back in here, move git move Flux system pod info back, git commit -m, and move things back, git push, clear as, and now we should be back. Yeah. Now let's try something different. Kubectl. Where was it? Okay, customization. This should be back in place now. Not yet. Not yet. See, this is one of the inconvenience of GitOps. You are stuck waiting for the reconciliation loop to run before syncing those things, and I've seen people not liking this. Now, in most cases, I didn't have any problem with this because you are gonna wait in any case some time, but people want a more reactive system. See, it took a moment. It's there now, but it took a moment. It had to rerun the reconciliation loop in order to see that there were changes. There you go. It applied everything. So we're back to where we were before. You've seen that how this is also an advantage, right? I was able to put it back and restore the previous state. Imagine if I was reverting instead of doing what I've done, right? You can actually revert back the history and have the same situation you had before. So quite convenient because it's idempotent if you want. It is actually idempotent, right? I can redo this over and over again. It should work from the perspective of GitOps. But let's see if I change something in here. Will it reload itself? So let's say that if I want to mess up this one, and if I want to change cluster into clusters and commit changes, there, I don't need my password. Yoo-hoo. So git status, git pull. No, I'm not going to pull now. So kubectl also because I want to close this stream. It's going to take too much time. So this is the last test, right? What am I trying to test with this? I want to see if it's actually reloading its own configuration. And we change the customization. Dash and cube Flux system. In theory, if that works, we should see things breaking really soon, right? False. So it does, okay, see, it does moderate itself, right? So it's probably going down, and as I say, it's probably recursively looking at the directories. In this case, it reloaded the customization. I have seen that the stat my cluster doesn't work, no such file directory. But does it remove the pod info now? It doesn't, because since that is not valid, it's not changing anything, right? It stopped before running any reconciliation. If that's not there, it's not gonna leave whatever that is told. But if that was an existing directory, it was empty, was it deleting everything? Probably. So as I told you now, let's assume that I want to roll back. So we're going to change it again. Flux system, sync, go in here, edit, put it back as it was, cluster, apply the changes in main, because, I mean, who needs protected branches and so on, right? So give it a second. Ooh, no, it's not going to work. It's not going to work because now I've broken that reconciliation loop. I've broken it with this. So reverting back in Git is not enough. So what I need to do now to fix it, I actually have to fix it manually, right? So I need to do edit, customization, Flux system. And then I need to go down here, find where the path is defined that is near, put it back to the path that is expected to be, save, go back, and there you go. This is true again, and is happily reconciling with whatever is near. So job done. I think we're gonna stop here for, and we can also see that the revision is actually the one that we expect. You see this is exactly the same hash, right? So it's CF92, CF92. Again, we're probably gonna stop here for today. Thanks a lot for watching. If you're watching this on YouTube, please like and subscribe. It really helps growing the channel, and I hope to share more with you next week. Thank you. Bye.